Hello and welcome. This is our first video for real numbers. I hope you all had a great time off after your class 9 exams. So welcome. So in this video we are going to learn what is Euclid's division lemma. Now because Euclid's division lemma, it sounds like it has to do with division, right? And what is the meaning of the word lemma? Lemma simply means a statement that has been proven to be true, and we use that statement to prove other statements. So let's do one thing. Let's take a look at some division of regular numbers, right? So here, let's randomly take some pair of numbers. So how about we take the number 15 and let's try to divide 15 by 4 and see what happens. So how are we going to actually do this division? So we divide the bigger number by the smaller number. So we say 15 divided by 4. So 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 fours are 16. So we write 3 here. And then this will be 4 3s are 12 and 15 minus 12 is 3. Can we divide any further? We can't because we have a remainder which is smaller than divisor. So the actual division process stops here. Let's take one more example. How about this time we divide the number 100 by maybe let's say 8. So how are we going to do this division? So we are going to write 100, which is a dividend here, and we will write 8. So we'll take the first two digits. So here, so it will be 8 ones are 8. So 10 minus 8 is 2, and then this 0 will come down. Now 8 ones are 8, 8 twos are 16, 8 threes are 24. So we can write 2 here, 8 twos are 16. And now 16 minus, I should say 20 minus 16 will be 4. And at this point the division process will stop again because 4 is less than 8. And let's take a look at one other random example. So this time maybe let's do something like maybe 25. Say 25 divided by 5. So how are we going to do this division? It's really straightforward. So if we do this division, so it will be 5 5s are 25. And basically we are going to get the number 0 right away. So the division process stops. Now you may be wondering, what is so unique about this? This is how we have learned division from our first grade. Always whenever we do divide two numbers, this is how we do our divisions, right? And it is true. And also, if you note, how do we write the dividend? So we say the dividend, in this case, let's say it is 15. So 15 actually is written as, 15 will be the divisor times quotient. So divisor times quotient plus the remainder. And let's quickly double check. So 4 3s are 12 plus 3 15. 15 equals 15. Similarly here we can say the dividend here is 100. So 100 is equal to divisor 8 times quotient plus remainder, right? So this will be 96 plus 400. And here we will have dividend I should say is 25, which is divisor times quotient plus remainder, which is 0. So again, all of these things are always true, and this is how we do regular division. So how does Euclid's division lemma fit into this? So let's find out what is actually Euclid's division lemma. So the definition of Euclid's division lemma is as follows. If we have any two given positive integers a and b, there exist unique integers q and r that satisfy the equation a equals b times q plus r, where r is greater than or equal to 0 but less than b. So note here, if we divide the number a by b, what happens? So let's try to visualize how this may look like. So we will write our dividend like this, and b will be our divisor. So we will get some quotient, and eventually we will get some remainder, right? And once we have this, so we can express our dividend here, a will be equal to the divisor, which is b, times quotient plus r, which is going to be the remainder, right? And the value of r will be such that it can be greater than or equal to 0. Remember in the third example r was 0, but r cannot be actually and it must be less than b. R cannot be equal to or greater than b, right? So this is when the division stops. So what we are noticing is that Euclid's division lemma is really nothing but how we have been doing division all our lives up till this point. And it is true. In the next video, we will learn about some applications of Euclid's division lemma.